Good morning, Year 11s. Today we are continuing linear algebra, and today we are attempting to tackle the toughest section of linear algebra, and that is solving algebraic word problems. Now these are tough because there's no perfect way that we can attack them that will always work. So for example, when we were attacking simple algebraic problems last lesson, we could do Bay, or expand brackets before anything else, expand and simplify, collect all the terms on one side, and then we could go to Shrek or start unwrapping those layers around the X to get it by itself. But with algebraic word problems, there is no exact solution or no exact formula that will get you the answer. So instead, I've written down 5 guiding steps that will help you not only get the answer, but maximize the marks from the answer. Can you please take out your notebooks and write them down? Now you'll have seen similar steps before. Essentially, number 1 clearly is reading the problem, and I can't stress that enough. Secondly, define a variable, and you do need to include a little sentence in there saying let x be. You don't have to use x, but traditionally we do. Then write an equation, solve the equation, and then finally answer the question in words. If you're given a problem in worded form, you should expect the answer to be given as a worded form. Alright, so once again, do pause me if I'm going too quickly. I'm going to go through several examples today. I'll do them pretty quickly, and then I'll let you do some practice on your own. Alright, the most basic form of question is written like this. When a certain number is quadrupled and subtracted from 27, the result is 7 more than the number. Find the number. We've read the question. We now have to define the variable. If there's ever any doubt, the easiest way to think about it is if they ask you to find something, whatever they ask you to find tends to be the variable. So we can say, let the number be x. Alright. When a certain number is quadrupled, well, that means 4 times the number, and then subtracted from 27, so 27 minus quadruple, the result is 7 more than the number. Okay? Now, we have an equation, so we need to solve it. We need to get all the x's on one side and all the numbers on the other. I would start by doing this by adding 4x to both sides. This gets rid of the x's on the left hand side and moves them all to the right, leaving us with 27 is equal to 7 plus 5x. Then we start unwrapping the x. I know it's on the right hand side, but it doesn't actually matter too much, as long as we end up with all the numbers on one side and all the x on the other. Subtract away 7 from both sides. 20 is equal to 5x. Divide by 5. Divide by 5. X is equal to 4. But normally we answer like that, just by convention. Alright, now we've worked out the number. We need to write a simple sentence answer. So if it asks us find the number, we can just say the number is 4. Alright. You'll all have seen this type of problem before. The how old is yada yada yada. Now, first of all, read the problem. A man is currently 3 times as old as his son. 4 years ago, he was 4 times as his son was then. How old is his son now? Alright. This gives us a clue of what x bit should be. Let x be the son's age now. Now with these age problems, what works really well is if we draw up a table. You have rulers, yours will be neater, and in this table we have the man and his son, we have now, and we have the other time period. So in our case, it is 4 years ago. Now what we've said is, let the son's age now be X. So we put the son's age in there as X. And if a man is currently 3 times as old as his son, which it says in the first line, and the son's age is currently X, then the man must now be 3X years old. Right. Now we fill in the other time period. And simply, if the son is now X, 4 years ago he was X take 4. If the man is now 3X, 4 years ago he was 3X take 4 years old. Alright. Now once we've got those two cells, we use the final, we use the final piece of the information to link those two. And that says 4 years ago he was 4 times as old as his son was then. What that is saying is that this value here is 4 times as large as that value there. So for example, if the son was 5, the man would be 20. Slightly worrying numbers. If the son was 10, the man would be 40. That's better. So we could keep guessing, but instead we could take this lower number and multiply it by 4 to get this upper number, get it equal to the upper number. So taking this lower number, which is X take 4, and multiplying it by 4, we're going to equal the older number. Alright, now we have an equation we can solve. Before anything else, we expand brackets. 4x minus 16 is equal to 3x minus 4. Get all the x's on one side. Get x by itself. X equals 12. Now remember what we define x to be in the start. X was the son's age now. And it asked us to find how old is his son now. We found what x is, so we need to answer the son is now 12. Alright, one more. Apples cost 27 cents each, oranges cost 21 cents each. Nadia buys 5 more apples than oranges, and the total cost is $3.27. How many apples and oranges did she buy? Alright, now here the question doesn't let us know what x can equal exactly. It essentially gives us a choice. We can let x equal apples or x equal oranges. Shall we say x equals apples? Let x equal the number of apples. Alright, so if she buys 5 more apples than oranges, and x is the number of oranges, x is the number of apples, then we can say that oranges are equal to x take 5. So there are 5 more apples than oranges. Now we use this equation. We can set up an equation using the cost of each of apples and oranges. If apples cost 27 cents and there are x number of them, then the total number of cents spent on apples will be 27 lots of x. And I'm sorry I'm going through this quickly. If oranges are x take 5 and they're cost 21 cents each, then the total number of cents spent on oranges is 21 lots of x take 5. And if we add this together, it will give us the total amount of cents we spent in total, which is 327 cents. Now we need to expand and simplify. 27x plus 21x, take 21 times 5 is 105. That's going to equal 327. Collect like terms. 48x, take 105 is equal to 327. We need to add 105 to both sides. (48x) is equal to 432. Here's where my mental arithmetic lets me down. We need to get x by itself by dividing both sides by 48. X is equal to 9. Therefore, she has 9 apples. And if x is equal to 9, from this, we can say she has 4 oranges. And we need to answer that in a question. So we say she has 9 apples and 4 oranges. Can you please go to page 77 and have a go at questions 1 to 14? Thank you very much.